Okay. After a H virus inserts itself into a chromosome of an animal, fragments of the virus are passed on to all of that animal's descendants. Okay. A H virus fragment is present in a chromosome of the zebra finch and in precisely the same location in a corresponding chromosome of the dark-eyed junco. Okay. The fact that these two bird species diverged from each other about 25 million years ago, therefore means that the H virus is at least 25 million years old. Okay. At first I was like, zebrafinch is a land animal, but then I realized it's a bird. Okay. So I was like, that's the flaw here.
Yeah, no, same. I'm like, wait, what? Yeah, though I think they put it in there just to distract you, right?
Yeah, for sure. So which of the following is true most strengthens the argument? Okay, so I think the conclusion is therefore this means that the H virus is at least 25 million years old. Why? Because the two birds diverged from each other about 25 million years ago. Okay. And then the H virus is found in the chromosomes of these two birds. Okay. So I think what would strengthen this is maybe going and thinking like a preface of like, this virus maybe didn't exist before 25 million years ago, or something that shows that like it had to have been at least 25 million years old in order to guarantee this conclusion.
Yeah. So why do we think that the H is at least 25 million years old? Because we have these two things, right? We have the zebra and we have the junco, and they both have it now, right?
Yeah. And then they diverge, they split up from their areas, I guess, or their
25 million years ago, right? So just
yeah.
the fact that they both have this now, actually, I feel like I should draw this the opposite. So they're trying to assume that so we have this, we have know how long that is. So we have our zebra and we have our junco.
Yeah.
And they both, I'm going to circle it, they both have this chromosome.
Chromosome, yeah.
So since they both came from whatever animal this is at one point up here, they're assuming that this thing also had that chromosome, right?
Yeah, because it passed down.
They're assuming so, right?
Yeah.
So what would strengthen the idea that, and this happened 25 million years ago, that this thing is at least 25 million years old?
That maybe before 25 million years ago, there's evidence that shows it didn't have this chromosome. Or something that would say like,
how would you destroy this argument if you were on the opposite end?
that maybe one of the two,
like, is it for sure
birds, yeah, I would say one of the two birds didn't have this chromosome during that time or something like that.
But if they both got it from something else,
yeah, like a third
like
party
later on, like these other things are like merging into it, I should describe, like, who knows, like could there be like multiple ways of us getting to these species?
Yeah.
So how I would strengthen this is by showing that like no other, like they didn't get it from anywhere else. How I would strengthen it.
Got it. Okay, so there's like no alternative explanation.
Yes.
Okay.
All right, so then what would you do next?
All right, so then I would, obviously I read the question stem already, and then I pre-phrased, so now I would probably go into the answer choices, A through E. So A says viruses can affect the evolution of an organism and can thereby influence the likelihood of their diverging into two species. Okay, but that doesn't, I don't think that helps strengthen the conclusion. If it can affect the evolution and influence,
that has nothing to do with it being 25 million years.
Like it influencing the likelihood of diverging, like that's fine, but it's not talking about how in fact it
could have happened in other places. Excellent.
Yeah. The chromosomes of the zebra finch and the junco contain fragments of no virus other than the H virus. Okay, maybe. because then if the chromosome has only the H virus and they diverged 25 million years ago, maybe then it was present 25 million. I don't know. I would keep B just to see if I like the other ones.
Okay. We'll leave it.
When a virus inserts itself into the animal's chromosome, the insertion occurs at a random spot. Okay, it doesn't matter where it was. It's still inserted. So I don't like C.
Okay. So this is what makes this question so hard. Let's leave C open for a second.
Okay.
B.
Maybe I missed something. It just seems like if it's inserted into a random spot, I don't know what random spot means. Like, does it mean like in their genetic chromosome? I don't know what that means. So that's why I was like not sure. But I'll move to D. Many bird species other than the zebrafinch and junco contain fragments of H. Okay, so if these other birds have it, that doesn't necessarily mean though that they came from the other birds. So, okay, I don't like D.
Nope.
The presence of H in an animal species does not affect the likelihood of that survival. Who cares? Okay, I don't care about the survival. I care about the fact that it existed.
All right, so
Okay.
go ahead and read the stimulus again.
All right. So after a H virus inserts itself, oh my God, there it is, into a chromosome of an animal, fragments of the virus are passed on to all of the animal's descendants. A H virus fragment is present in a chromosome of the zebrafinch and in precisely the same location in a corresponding chromosome of the junco.
Okay.
I saw that too. The fact that these two bird species diverged from each other about 25 million years ago, therefore means that the H virus is at least 25 million years old. Oh,
What's our answer?
it's C.
And why?
Because if you say this answer choice is true, then it supports the premises that support the conclusion that it was precisely in the exact same location, that it
If we have two animals and they both have this chromosome on the exact same spot, but whenever this chromosome enters an animal, it's at random. Well, then if these two animals are in the same spot, it's more likely that they got it at the same time.
Yeah. Wow, that's tough. Okay, so let me go through B. Sorry. The chromosomes of the zebra and the junco contain fragments of no virus other than H. Okay, so I guess B is not right because it doesn't matter if there's no virus other than H. It's you're trying to
They
that
could have
H
multiple.
was alive during at least 25 million years ago. So it doesn't do anything to strengthen that conclusion.
Fabulous. And that's
Oh my God. If this was the test, I would 100% pick B because I would gloss over the precise exact same location and stuff.
So whenever you are down between two, especially like since you're scoring at such a high level, don't be afraid to reread the stimulus or reread the conclusion when you're debating between two answer choices. You're like, I just don't know. But I think you would